welcome to Eternal Easy Education. In this session, you are going to learn Chapter 2, Number System. Content of this video is Encoding System. The encoding system present in your syllabus are BCD, ABCDIC, ASCII. This is ASCII, UNICODE, and ISCII. Let us see in detail. So, representing characters in memory. As we know, all the content in the computer is in the form of digital. That means bits, 1010 format. As represented in introduction, all the input data given to the computer should be understandable format. In general, 26 uppercase letters, 26 lowercase letters, and 109 digit and special characters are used. So, the keys present in the keyboard, these are the keys. So, using the keys only, we are typing something and storing the content in the memory device. This is said to be character set. All these character set are denoted through numbers only. That means in computer, it is going to be represented in 10 format. Before that, it is having a number. All the characters in the character set needs a common encoding system. Common encoding system means if a computer used in a country like India, and also the same computer is used in another country. So each one is using the keyboard for typing the content. Am I right? So there is a standardization. That means key in the keyboard represent a particular number which is to be common throughout the world. So this standardization is given by the encoding system. First one is binary coded decimal. So what is that? This encoding system is not in practice now. So the first point is it is not in practice. This is 2 to the power 6 bit encoding system. This handle 64 characters. So the number, for example, take the letter A. If it is a capital letter A, then it is 65. How you are saying is that it is 65? I show the tabular column. So this is the American Standard Code for Information Interchange, ASCII value. Most probably ASCII value is used throughout the world, but because of the introduction of new languages, there are many coding systems, but this is for English, especially for American English, as the first thing they used or developed is through English language. It is based on that. See here, the capital letter A represents 65. So, if I press A, for example, if I type a letter A-P-P-L-E, apple means, for us it may look like apple, but for the computer in the memory, the A is treated as 65 and this 65 number is converted into binary. You know very well how to convert the decimal to binary. This is the conversion part, and the octal and the hexadecimal. So these things are used only in the computer system. So only we are learning number system. Number system, why we are learning means the number system is the conversion of the numbers which are going to be handled in the memory unit by the CPU, Central Processing Unit. So the next letter is P. Okay, so the P letter is 80. And again the letter P is represented as 80 and L is represented as 76 and E is represented as 69. So these numbers, you may think simply it is apple, but actually it is below. That means in the background the apple is 65, 80, then 76, 69, and all the numbers are converted into binary and it is stored in the memory unit. But these things are done within a fraction of seconds. So we are unaware of what is going in the background of the CPU. But being a computer science, you are knowing that while you are typing something in the keyboard using the keys, all the keys are having a particular number in common throughout the world. That number is converted into binary and that is stored in the CPU. Is it clear? CPU in the sense, in the CPU in the memory unit. So the ASCII value, American Standard Code for Information. This is most popular encoding system recognized by United States, and this can handle 2 to the power 7 bit, which means 128 characters. We have seen this tabular column now. The new edition is revised, so it is handling 2 to the power 8, that is 256 characters, and it represents from 0 to 255 unique numbers. So we know that capital letter A is equivalent to 65. Then Extended Binary Coded Decimal Interchange Code, EBCDIC. These things may come for 3 mark or 2 mark. Sometimes it may come for 5 mark as explain the encoding system. This is similar to ASCII code with 8-bit representation. This coding system is formulated by IBM, International Business Mission. The coding system can handle 256 characters. The input code in ASCII can be converted to EBCID and vice versa. The next one is the Indian Standard Code for Information Interchange. This system of handling the characters of Indian local languages. So this is also 8-bit coding. This is also capable of 256 characters, 2 to the power 8. This system is formulated by the Department of Electronics in India in the year 1986 to 88, and it is recognized by Bureau of Indian Standards. Now this coding system is integrated with UNICODE. That means it is merged. UNICODE. What is UNICODE? This coding system is used in most of the modern computers. So popular is ASCII, but the most used are UNICODE. The popular coding scheme after ASCII is UNICODE. ASCII can represent 256 characters. Therefore, English and European languages alone can be handled by ASCII. Particularly, there were a situation when the languages like Tamil, Malayalam, Kannada, Telugu could not be represented by ASCII. Hence, the UNICODE was generated to handle all the coding systems. So, UNICODE was generated to handle all the coding systems of universal languages. And this is 16-bit. And it is able to handle 65536 characters. Unicode scheme is denoted by hexadecimal numbers. You know very well which is hexadecimal number. And it is able to handle Tamil, Malayalam, Telugu and Kannada. So here they have given the ASCII value. That means a hexadecimal number for each letter of a language. Most probably one word will come only for this ASCII value, so have a look. No need to memorize, just you know if the starting letter of A is 65 means you can able to calculate the other numbers easily. Likewise, the small letter A always starts with 97, so from this you can calculate the balance numbers. Okay, the special characters also having decimal numbers and binary numbers. That means it is equivalent to, for example, the blank space is equal to number 32. So you have learned procedure to convert fractional decimal to binary, and we have done this in a previous video. And what is 1's complement and 2's complement? These things will come only for the negative numbers. And you know addition and subtraction very well. So these things we have covered in this video. So we completed the chapter 2, part A. This is for CA, that means computer application students. Computer science students will have one more part. That will be easy for them. For CA students, the second chapter is over. Thank you. Have a good day.